Good day, students! In behalf of your teachers, I welcome you back to another learning video in Mathematics 8. I am Teacher Isa, the one who will be with you in learning about linear functions. In today's session, we are expected to evaluate linear functions, determine whether an equation is a linear function or not, and graph and illustrate the linear function and its domain, range, table of values, intercepts, and slope. Are you ready? I hope you are. In the first grading period, we have learned about linear equations. Today, we are going to tackle about linear functions. What is a linear equation? A linear equation is an equation that can be written in the form ax plus by is equal to c. Take note, a, b, and c are real numbers, and both a and b cannot be 0. On the other hand, a linear function is described by the equation y is equal to mx plus b. In the function notation, the equation of a linear function is written as f of x is equal to mx plus b. Take note, in both equations, m and b are real numbers, and the exponent of x is 1. Let us repeat reading the function notation of a linear function. Repeat after me. F of x, your turn, is equal to mx plus b. This time, do it on your own. The domain and the range of a linear function are real numbers. In symbols, the domain is the set of all x such that x is an element of the real number system. On the other hand, the range is the set of all y such that y is an element of the real number system. Recall what we have learned on relations. The domain is the collection of all first elements, and each first element is represented by the variable x. And the range is the collection of all second elements, and each second element is represented by the variable y. Let us state whether the given equation is a linear function or not. Let's have f of x is equal to x plus 1. By definition, this equation is a linear function. Why is that so? Because the exponent of x is 1. Therefore, equation number 1, again, is a linear function. Next, what about g of x is equal to x squared minus 4? Again, if we make use of the definition of a linear function, this equation is not a linear function. Why is that so? Because the exponent of x is not 1. Therefore, g of x is equal to x squared minus 4 is not a linear function. And lastly, what about 3x plus y is equal to 6? Is it a linear function or not? 3x plus y is equal to 6 is a linear equation that can be transformed in the form y is equal to mx plus b. Let's do that. Remember, our goal is to transform that equation in the form y is equal to mx plus b. Therefore, we need to transpose 3x to the right side of the equation so that it is only the y term which is left on the left side. So if we do that, we shall be having y is equal to 3x will be transposed from positive, therefore it will become negative. 6 is not transposed, therefore it remains positive. In doing so, we have proven that 3x plus y is equal to 6, which is transformed into y equals negative 3x plus 6, is a linear function. This time, let us evaluate linear functions. What does evaluate linear functions mean? It means that we are going to write the given linear function in the form y is equal to mx plus b or f of x is equal to mx plus b. So, let's start with this. Given the linear function f of x is equal to 5x plus 2, evaluate f of 3. How do we do that? Simple. Follow me. Every x in the given linear function should be substituted with 3. So in the given linear function, f of x is equal to 5x plus 2. Every x will be replaced with 3. So we have here f of 3 is equal to 5 times, we change x to 3. So we have 5 times 3 and add 2. Let's simplify. Take note, we are not going to multiply f by 3. We are not going to do that. Why not? Because f of 3 simply means we evaluate the given function at 3. This is actually the name of the function. So we have f of 3 is equal to, this time we are going to multiply 5 and 3. 5 times 3 is 15. We copy 2. Simplify the right side of the equation. We have f of 3 is equal to 17. Thus, f of x equals 5x plus 2 when evaluated at f of 3 is equal to 17. Let's have our second example on evaluating linear functions. Given the linear function g of x is equal to negative 2x plus 1, evaluate g of b plus 2. We are going to do the same process that we have done in the first example to answer our second example. This time, what will replace all the x in the original function? What is it? It is b plus 2. So, in the original function, g of x is equal to negative 2x plus 1. Every x that we see should be replaced with b plus 2. Let's do that. G of, what will we replace x with? B plus 2. B plus 2 is equal to negative 2 times the quantity b plus 2, don't forget the plus 1, plus 1. Okay, next. Are we supposed to multiply g and the whole of b plus 2? No, we're not supposed to do that. So, what are we going to do? We simply copy it. G of b plus 2 is equal to, what about negative 2 and the whole of b plus 2? Are we going to multiply them? Yes, so let's do that. Negative 2 times b is negative 2b. Next, negative 2 times 2 is negative 4. Do we multiply negative 2 and 1? No, you're just going to copy plus 1. Next, if we can further simplify, we need to simplify. Can we combine similar terms through addition and subtraction in the right side of the equation?
Yeah!
Yes. So we have here g of b plus 2 is equal to negative 2b. We can simplify negative 4 and 1. What's negative 4 plus 1? It's negative 3. Since we can no longer combine negative 2b and negative 3, it's already the final answer. Take note, when we evaluate g of x equals negative 2x plus 1 at b plus 2, the value of the function is negative 2b minus 3. Let's have a deeper understanding of what linear functions are by having some more discussions on its characteristics. It was mentioned earlier that a linear function is described by a linear equation. However, not all linear equations are considered linear functions. Let's find out more about this using these graphs. Let's take a look at the graph of the equation y is equal to 5/3 x minus 5. It is a line with a positive slope. Why? Because it is rising from left to right. What about the graph of y is equal to negative x? What is its slope? The line falls from left to right. Therefore, its slope is negative. Let's move on to the graph of y is equal to 4. Its graph is a horizontal line. Therefore, its slope is 0. And lastly, what about the graph of x is equal to -5. How does it look like? It's actually a vertical line. Therefore, it has an undefined slope. Using the vertical line test, which among these graphs is not the graph of a function? It is the one with an undefined slope, because the vertical line passes through the graph more than once. Therefore, all linear equations in the form x is equal to a and whose graph is a vertical line is not a linear function. Now, let us investigate another characteristic of linear functions using the equation y is equal to x plus 1 or f of x is equal to x plus 1. Take note, y and f of x mean the same. The following table shows the corresponding values of f of x, which means y, given the x values -2, -1, 0, 1, and 2. In the table of values for a linear function, take note that the difference from one x value to the next, from one x value to the next, from one x value to the next, and so on and so forth, is the same. What about the difference from one y value to the next, from one y value to the next, from one y value to the next, and so on and so forth? Let us subtract the lower value from the higher value. So we shall be having 0 minus -1. What is it? 0 minus -1 becomes 0 plus 1, and 0 plus 1 is equal to 1. Next pair. 1 minus 0. 1 minus 0 is equal to 1. Next pair. 2 minus 1. 2 minus 1 is equal to 1. And last pair. 3 minus 2. 3 minus 2 is equal to 1. What do you observe regarding the differences in the y values? The differences in the y values are the same. Thus, the table of values for the linear function shows that equal differences in x produce equal first differences in the y values. In case the first differences in the y values are not the same, for example, 1 here, just in case, is -1. The first differences in the y values are not the same. What can we say, therefore, about the given equation? The given equation, if the first differences in the y values are not the same, is not a linear function. But since the first differences in the y values for y equals x plus 1 are the same, the given equation is the equation of a linear function. This time, let us discuss the last set of characteristics of linear functions. Given this graph, we're going to determine its domain and range, x and y intercepts, and the slope of the line. Let's start with domain and range. Oh, but before we do that, let us first determine if the given graph is the graph of a function or not. Vertical line test. At how many points did the vertical line pass through the given graph? At exactly 1 point in any part of the graph. Therefore, what can you say about the line? Is it the graph of a linear function?
Yeah!
Yes, it is. So, we are now ready to determine its domain and range. By definition, the domain and the range of any linear function are real numbers. Therefore, the domain of the given graph is the set of all x such that x is an element of the real number system. Its range, on the other hand, is the set of all y such that y is an element of the real number system. Next, what about its intercepts? Take note that the intercept of a graph is a point along the x and the y-axis that the graph passes through. Thus, its x-intercept is... What point is that? Its x-intercept is 2. What about its y-intercept? Its y-intercept is 1. Let's move on to the last. This time, its slope. Let's determine its slope by using the concept of rise over run. Slope is equal to rise over run. When we say rise, we either go up or down. If we go up, it is positive. If we move down, it's negative. For run, we either go to the left, that would mean negative, or to the right, which means positive. So, let us determine any 2 points on the line. Let's have the intercepts. From point A to point B. Let's determine the slope. So, we go up 1 unit, therefore the rise is positive 1. Then, to go to point B, we move 1, 2 units to the left. That's why its run is negative. Is it true for any pair of points on the line? Let's find out. So, let us move from point B to point C. We go up, then left. 1 unit up, 2 units to the left. What about from point A to point C? Let's see. 2 units up, that would be 2. And then 1, 2, 3, 4. 4 units to the left. Is 2 over negative 4 the same with 1 over negative 2? Yes, they are the same. Why is that so? Because 2 over negative 4, when simplified, is the same as 1 over negative 2. Therefore, the slope is negative 1/2. In this learning video, we have learned that the form of a linear function is given by the equation y is equal to mx plus b, or f of x is equal to mx plus b. The domain and range of any linear function is the set of all real numbers. Given a table of values, we can know that it is for a linear function if equal differences in x produce equal first differences in y, and that all linear equations are linear functions except for x is equal to a, or a linear equation whose graph is a vertical line. In the first part of this learning video, we have learned that using these concepts that we have learned on linear functions, we are now ready to solve problems involving linear functions. Specifically, we are going to write a rule or equation for the linear function and solve word problems that involve linear functions. Here's our first situation. Maria receives 200 pesos a day as a garden assistant and an additional 10 pesos per plant she sells. Write a function that relates the amount Maria is paid to the number of plants sold. To solve this problem, let us identify the quantities we are looking for. In this statement, we are given that, or we are told that, we need to find out the number of plants sold and the amount Maria is paid. Therefore, there are two quantities unknown. So, we let each quantity be represented by a variable. Let us have the variable x and the variable y. Usually, when we talk about functions, x is our independent variable, while y stands for our dependent variable. Which between the two values or the two quantities is independent? Is it the number of plants sold or the amount Maria is to be paid? In other words, which should come first? Should Maria sell first or should Maria be paid first? It is Maria should sell first before being paid. Therefore, the amount she is paid is dependent to the number of plants she will be able to sell. Thus, X would stand for the number of plants sold, while Y stands for the amount Maria is paid. But we haven't written our function yet. Let's go back to the first sentence. Take note, Maria receives 200 pesos a day as a garden assistant, therefore that is constant, and an additional 10 pesos per plant she sells. Thus, the amount Maria is paid is equal to 200 pesos, her daily wage, plus the number of plants sold multiplied to 10 pesos. Here now is the function we are looking for. Y is equal to 10x plus 200. Next, how much does Maria earn if she sells 5 plants or 15 plants in a day? For us to know how much Maria would be able to earn, we are going to make use of the equation we have obtained in letter A. The equation is y is equal to 10x plus 200. Remember, x is the number of plants sold, while y is the total earnings of Maria. So, for this situation, y remains as is. That is what we are looking for. The earning. 10 times x will be substituted with 5. And then we add 200. Let's simplify. Y is equal to 10 times 5 would be 50. 50 plus 200 is equal to 250. If she would have to sell 5 plants, she would be receiving 250 pesos for that day. If she would be able to sell 15 plants, on the other hand, she would be able to bring home a total amount of 10 times 15 plus 200. 10 times 15 is 150. We add 200 pesos and 150 pesos. That would be 350 pesos. Here are Maria's earnings for the respective number of plants she would sell in a day. This time, let us answer the last question. If she is paid an amount of 300 pesos, how many plants did she sell? Let us first compare the difference between question B and question C. In question B, we are given the number of plants sold. In question C, we are given the total amount Maria was paid. Thus, Y will be substituted with 300, and then we are going to solve for the value of X. So, in the equation, Y is equal to 10x plus 200. We shall be having 300 is equal to 10x plus 200. Our first goal here is to isolate the term with the variable x. We can do that in two ways. First way, we subtract 200 to both sides or in both sides of the equation, or we do what we usually make use of. That is the process called transposition. So, we transpose 200 to the left side of the equation. Thus, we are left with 10x, or we have isolated 10x to the right side of the equation. So, we shall be having 300 minus 200 is equal to 10x. Let's simplify. This will give us 100 is equal to 10x. And to get the value of x, we divide both sides of the equation by 10. Thus, the value of x is equal to 10. Therefore, if Maria is paid an amount of 300 pesos, she had sold 10 plants for that day. Second situation. At a paid parking area, a driver pays an initial amount of 50 pesos plus 20 pesos for every hour of parking. If the driver parked for 4 hours, how much will the driver pay? Our first goal for this particular situation is to write the linear function representing it. So, we need again to find out what the unknown quantities are. We have an initial amount to be paid that is already known, and 20 pesos for every hour of parking. Next, letter A. The driver parked for 4 hours. How much will the driver pay? Okay. In this sentence, we are now able to determine which are the dependent and independent variables. Again, which should come first? Are we going to pay first? Or are we going to park first? We should park first and then determine the length of time we are going to park before we can be able to compute for the amount, for the total amount we need to pay. Thus, in our representation, we let x as the number of hours parked, while y, the variable y, is the total amount to be paid. So, our working equation is y is equal to the initial amount to be paid, 50 pesos, plus the number of hours parked multiplied to 20 pesos, which is the amount to be paid for every hour. So, we are going to make use of this equation to solve for question A. The driver parked for 4 hours. 4 hours. Should it be for X or should it be for Y? It is for X. Y, therefore, is equal to 20 times 4 plus 50. Let's simplify. Y is equal to 20 times 4, that is 80. 80 plus 50 is equal to 130. And what does 130 mean? It means that if the driver parks for 4 hours, he would have to pay 130 pesos. Question B. If the driver paid 190 pesos, how many hours did the driver park? In this particular question, we are going to make use of the same equation that we have used to solve letter A. Y is equal to 20x plus 50. But this time, we are not given the number of hours the driver parked. That is what we are looking for. We are given the total amount the driver paid. So, which variable are we going to change to 190? Is it the variable y or the variable x? Let's find out if your answer is correct. Y is equal to 20x plus 50. Y will be changed to 190. Remember, y stands for the amount, and the amount is 190. And this is equal to 20x plus 50. We are looking for the number of hours parked that is represented by the variable x. So, we again need to isolate the term with the variable x. We make use of the long method, the APE, by subtracting to both sides of the equation 50, or simply make use of transposition. Let's do that. We have 190 minus 50 is equal to 20x. The left side of the equation, when simplified, is equal to 140. The right side of the equation remains as 20x. We need the value of x, so we apply MPE. We are going to divide both sides of the equation by 20. After doing so, we are now left with the value of x, which is 7. What does 7 stand for? It stands for the number of hours parked if the driver paid 190 pesos. And the number of hours parked is 7. Congratulations, students! Another set of treasures has been added to your learning box. See you again next time for another set of lessons. G of B plus 2
Tinapos mo?
Let's find out. let us subtract the higher value
Lower value from the other.
okay. Let us subtract the lower value from the higher value. Let's do that. It is Maria should be sold first.
Huh?
Ano? Sisingit yun. See you again next time for a new set of lessons. Bye!